Have you ever wondered if there's an easy way to check your tank level without getting up and checking it yourself? Well, today I'm going to show you how, using a D1 Mini, a sonar sensor, Tasmota firmware, and a waterproof box. This will connect to your Home Assistant, and you can check your tank level at any time through your dashboard. Here's what we'll be using: a D1 Mini, an SR04 sensor, and a waterproof box to keep everything safe outdoors. I do recommend using this sonar sensor, but for the purposes of this project, I'm just going to use the SR04. The sensor will measure the water level inside the tank, while the D1 Mini, flashed with Tasmota, will process the readings and publish them over MQTT. First, go to this address, tasmota.github.io/install. I'll leave this address in the description below. Okay, so once we've gone to this address, we select Tasmota sensors. Click connect. I've plugged it into one of my USB ports. We go connect. Click install Tasmota sensors. Erase. Next. Install. They've really made this super easy to do. We always like to thank the people that make our lives easier. I'm not too sure who writes the software, but they definitely have made it easier. So just leave this in the foreground, as for some reason, if you do put it in the background, it does go slower for some reason, the installation. Okay, there we go. Next, we can specify the password, connect. Okay, and then we can visit device. All right, now let's move on to the configuration. Okay, to save time, I'll already set up my Tasmota, but I'll go through the configuration with you. Click on configuration, click on module. This by default is set to basic, Sonoff basic. We change it to generic, and then we set the D2 and D1, as that is where I've connected the trigger and the echo pins onto the board. Take note, if you install Tasmota, these options won't be available. They're only available in Tasmota sensors. Right, MQTT, we just set your host name, username and password. This could be your standard Home Assistant username and password, or you could set a different one for the mosquito broker. Right, and then other, I just set the device name and the friendly name to the same. This telemetry period is how often it will talk to Home Assistant. I normally set this to 60 seconds on a large tank, but you can set it to smaller or longer, depending if you're filling up your tank or not. But as this data is very small, it's not really too much of an issue. It doesn't create any major network traffic or anything like that. Now let's go over to Home Assistant to see what's happening there. Okay, now we're in Home Assistant. First things first, you would need to have installed Mosquito Broker. I have attached a link on how to install this in the description below. Okay, next we go to Device and Services. You need to have configured your MQTT and Tasmota. You can find both of those in Add Integrations. Once you've installed that, you go to Tasmota. You can see all my Tasmota devices, but we're going to go to the sonar sensor. And yeah, you can see all the information that Tasmota is passing off to it. This is the sensor we're really interested in, the SR04 distance. And you just want to make a copy of that name. because that's what we're going to use to create the percentage sensor in the next step. And nothing much more to this. Let's move on. Alrighty. Before we get started, first we need to make sure that the file editor is installed on Home Assistant. The tank height, which is the height from the bottom of the tank up to the lid where you're going to install the sensor. Your overflow height is the height where the tank will start overflowing. Finally, the total liters of the tank. This is South Africa. We do use the metric system. We're ready to go. Okay, so let's look at the YAML file configuration. Just a note on the configuration.yaml, I point all my objects to YAML files to split them up, just to make things look neat and orderly. And just so they don't look like my gran used to say, a dog's breakfast. I never understood that comment, as dogs must have been different back then, because my dogs leave clean bowls. Okay, let's head over to templates.yaml. Here I've created two sensors. One to give me the value from the lid to the water, and the other one to give me a percentage of how full the tank is from the overflow point. So first let's look at this one. Here I've set a variable for depth, and this goes on my sonar reading. Then I say 200 centimeters minus depth to give me a value of how far the water is from the lid. 200 centimeters is the height of my tank. Next one is I take that value and I set it as a variable here, and I've named it top. And then what I do is I say top divided by 190, which is the height of my overflow, multiply by 100 to give me a percentage. So very simple, and I will leave links to my code in the description below. Think of it like this. My tank is like my fridge. Every time I look inside it, it looks emptier than I thought it was. But at least with Home Assistant, I know it's not just in my mind. Now that we got all the data, how can we actually use this in the real world? Simplest option is to monitor the tank level and get notified when it drops below or rises above certain thresholds. You can also automate your borehole pump, turn it on when the tank drops too low and off when it reaches your set maximum. I usually stop mine at around 95%, so I never risk an overflow. Another handy trick is switching between a water tank and municipal automatically, opening and closing valves depending on the water tank level. And of course, log in the percentages over time. You can work out your household's water usage with surprising accuracy. I've been using a system like this for years now, and apart from a couple of hiccups in the beginning, we've never had water problems, while most of our neighbors still struggling with theirs. And that's it. A complete smart water tank sensor using a D1 Mini, a waterproof sonar sensor, Tasmota, and Home Assistant. No more guessing or climbing ladders, just real-time tank data on your phone or dashboard. If you found this useful, hit the like button, subscribe for more automation projects. And here's a fun one. Drop a comment below telling me how you would use this. Would you track your water tank? Or if a garage has a car in it? Or maybe even something completely unexpected. I'd love to hear your ideas. All right, thank you for staying till the end. Now I'm going to quickly show you a node-RED flow on how I control my water tank. Firstly, I use my water tank percentage to control this entire flow. And then I take that value and I insert it into a switch node if it's above 95% and if it's below 75%. So if it's above 95%, I have a 4-channel Pro that controls 4 solenoids: full pool, irrigation, full tank, and a spray. So what I do is I turn the full tank off. Then I delay 2 seconds. Then I check that that is off. And only if that is off, I turn the ball off. If it's not, I loop back to turn that solenoid off. This is just in case the device isn't available, so I'm not closing the valve, and then that turns on, and that becomes a problem if something else kicks off. All right, if it's below 75%, I go to that same solenoid and I turn it on. I delay 2 seconds, and then I check if it's on again. If it is on, I'll go and turn my borehole on. If it's not on, I'll loop back and turn it on again. So if this doesn't trigger, if this doesn't turn on, or if this device isn't available, and then the borehole turns on, well, the solenoid's closed, and then I get burst piping and I get leaks all over the place. That's my basic, simple management of my water tank. This has been serving me well for ages, and it works like a dream. Okay, thank you for staying, and I will see you in the next video.